Hello everyone. In today's lecture, we're going to be looking at implicit differentiation. As usual, I talk about the topics, the things we have learned earlier, and what we will be doing in this session. So previously, we have talked about finding derivative of functions using constant, power, constant, multiple, sum and difference, product and quotient, and chain rule. And then we also looked at derivative of trigonometric and higher order functions. And in this video, we are going to be looking at functions which are implicit, and then how can we find differential of these implicit functions. To do that, the first thing is we are going to distinguish between functions which are written in the implicit form and the explicit form. And then we will try to find the derivatives. So let's talk about the implicit and explicit functions. Now, when we talk of implicit and explicit functions, till now we have been looking at functions which are most of the time expressed in explicit form. For example, y equals 7x minus 4. The explicit form basically means that you can have y on its own on one side with the power 1 and coefficient 1. And every other variable is on the right-hand side of the equal sign. And with that, we can easily find differentials of y with respect to x. But sometimes we get functions like x squared plus y squared plus 3xy equals 16x. And now in this one, how do I get a y on its own in every element on the other side of the equal sign? So these kind of problems, it's very difficult to express y as a function of x explicitly. And these are the ones we call implicit functions. So in order to find the differential of these kind of implicit functions, we are going to have implicit differentiation. Now, certain things to keep in mind. That in order to find dy by dx implicitly, we have to realize first of all that the differentiation is taking place with respect to x. That means when you're differentiating terms which are x alone, then you do the normal differentiation. But when you have differentials involving y, you have to apply the chain rule. Because you're assuming here that y is defined implicitly as a differentiable function of x. So let's start looking at problems from a very simplistic angle, and then we will start doing difficult problems. Now let's look at this differential. Differential of x cubed. Now clearly the independent variable is x and the function is also in terms of x. Now here the variable and the function are basically agreeing. So we just do normal power rule and we get the answer to be differential of x cubed to be 3x squared. Now, let's look at the next problem. Now, in the next one, notice the differential is of y cube, whereas the variable which we're differentiating, that y cube, is of a different variable. So these variables are not agreeing with each other. So when there is a difference, when the variables don't agree, we are going to apply the chain rule. So here what you normally do is this. So for y cube, you're assuming that is u as a function of n, and you do the normal differential, but then in the end, you multiply by dy by dx. Now your u, remember, is y. Okay? So here my u is y, and my n is 3. So nice little chain rule comes up. So let's look at an example of differential of x plus 3y. So clearly it's a sum of two functions. So you take differential, so you can write this as differential of x plus differential of 3y. Now x and x agree, we definitely know it as 1. When you take the differential of 3y, notice you can take the 3 out and you're finding the differential of dy by dx. Now y to the power 1 is 1 times, so if you look at this one, it's simply nun minus 1. So you're applying the chain rule here. Okay, let's look at another example. We're looking at differential of xy squared. Now, the first thing you notice is in this one, you have to apply the product rule. So my x is the first function, y squared is the second function. So you're going to differentiate the first function. So this is d dx of x, and then times the second function, which is y squared, plus x times the differential of y squared. Now notice the x with the x is agreeing, so it is simply a 1, d dx of x, ddx of x is 1, whereas y squared is it comes out like that. Now the x1 is dy by d, so in the next one is x times the differential of y squared with respect to x. Notice the x and the y are not agreeing. So that simply says you got to apply the chain rule. So what would it look like? Plus x times 2y, you take the normal differential. So remember, you are looking at y squared as u to the power n. So the differential of y squared is the differential of un, which we know is nun minus 1 times u prime, where u prime is dy by dx. Or you can write this as nun minus 1 times dy by dx. That's what we have. And then just gather, do a nice little simple math here. So y squared with 1 is y squared plus 2xy dy by dx. And that's it. Okay, so these were simple rules on, simple ways and rules to do the differentials for implicit functions. Now, I'm going to show you some guidelines when you're doing implicit differentiation. The first thing is you leave the equation as it is and you differentiate both sides of the equation with respect to x. The second step is you get all the dy terms on one side of the left side of the equation and then move all the other terms to the right side of the equation. Then on the left side of the equation, factor the dy by dx and then you solve for dy by dx. So these are 4 steps involved. So you can write this as, say, this is step 1, step 2, step 3, step 4. I'm going to do a lot of problems for you guys, and you'll realize that step 1 is definitely going to be done every time. And then step 2 and step 3, sometimes you just do step 2, go to step 4, or you do step 2 and 3, and then 4. Okay, so let's look at that example, the first example. Find dy by dx for this equation x squared plus y squared plus 3xy equals 16x. So what is step 1? You're going to differentiate both sides of the equation with respect to x. So that means d dx of x squared plus y squared plus 3xy equals d dx of 16x. Now the right hand side is so simple, it's simply 16. Whereas the left hand side, we're going to go step by step. The first thing you do is, because this is a sum of different terms, we're going to take the differential of each one of them separate. So d dx of x squared plus d dx of y squared plus d dx of 3xy. Now, the first expression, x and x are basically agreeing with each other. It's a simple power rule. So it is 2x. But the next one, notice the x and the y square, they are not agreeing. So what you're normally going to do is apply the chain rule. So this will be, do the normal 2 times y times the differential of y with respect to x. Now, the third term, ddx of 3xy, it's a constant multiplied to a product of two terms. We're going to take the 3 out, and then you're going to look at the differential of x with y. So the first two terms just remain the same, and now we're going to apply the product rule here. So it's 3 times ddx, so this is x is the first term, y is the second term. So ddx of x times y plus x, which is the first term, and differential of y. Now what do you get? 2x plus 2y dy by dx plus 3 ddx of with x is 1 times y plus x times dy by dx and equals 16. So we, distribute the 3 inside. What do we get now? Is 2x plus 2y dy by dx plus 3y plus 3x dy by dx equals 16. So now we have basically solved till the very end here of the first step. So the next step in the implicit differentiation is you put all the dy by dx terms on the left side of the equal sign and take the rest of the terms on the right hand side. So in other words, 2x, 3y will go here on the right side. So what do we get? 2y times dy by dx plus 3x times dy by dx equals 16 minus 2x minus 3y. Now we can factor the third step, factor dy by dx. And what you're getting now is when you factor dy by dx, you get 2y plus 3x equals, the right hand side just remains the same. And the fourth step is basically getting the answer for this problem is solve for dy by dx. In other words, you want to have dy by dx with a coefficient 1. And then the final answer is dy by dx equals 16 minus 2x minus 3y divided by 2y plus 3x. Okay, let's go ahead and do another example, and this time we're going to get some trigonometric functions. So here we're going to find dy by dx implicitly for the equation cosine y equals x. So the first step, as usual, you're going to differentiate this whole equation. You're going to write ddx of cosine y equals ddx of x. Right side pretty simple, it's simply a 1, whereas the differential here, now remember cosine of y. So this x and y are not agreeing, so that means a chain rule. So you're going to differentiate this cosine. So remember the outer function is cosine, the inner is y. So the differential of cosine is negative sine y times the differential of the inner function, which is y. Now, step 2 is get all the dy by dx terms. So this is what minus sine y times dy by dx equals 1. So step 2 means get dy by dx on its own and every other term on the right hand side. So what we get is dy by dx equals 1 over minus sine y, which is basically minus 1 over sine y, and 1 over sine y is cosecant y. Now, the step 2 already gave us the final answer. So when you do problems, you'll be so surprised that sometimes step 2 only gives the final answer. Sometimes you have to do all these steps. Okay, let's do another example, this time with a combination of sines, cosines. Now it says find dy by dx implicitly for this equation x cubed plus 3 sine y minus y squared equals cosine x. Now remember, step 1 will always be there. Step 1 is differentiate both sides of the equation with respect to x. That means you will write this expression and in front ddx. Similarly, on the right hand side, ddx of cosine x. Clearly, cosine x is simple. You get negative sine x. We are done with that part. Now let's look at the left hand side. So individually, we're going to take the differential of x cubed sine y minus y squared. Now here, notice the x and the x are the same, but the second term has an x and a y, so now that's a little different. And similarly, the third term, the x and the y are again different. So for the first term, it's a normal differential, which is a power rule, 3x squared, plus 3 times sine y. Now remember, this is a chain rule. So your sine becomes cosine, so differential of sine is cosine y, times dy by dx, minus 2y times dy by dx minus sine x. So we have done all our differentials. Now we just have to gather the dy by dx terms on the left hand side and all the other rest of the terms on the right hand side. So when we do that, notice what happens. We are left with 3 cosine y dy by dx minus 2y times dy by dx equals negative sine x negative 3x squared. Now we have to factor out dy by dx. That's step 3. So we get dy by dx in square brackets 3 cosine y minus 2y equals minus sine x minus 3x squared. The fourth step is basically solve. That means the solving means the coefficient of dy by dx should be 1. So you take this term which is next to dy by dx in step 3 in the denominator of the right hand side. So your final answer is dy by dx equals negative sine x negative 3x squared divided by 3 cosine y minus 2y. Okay, let's look at one more problem. This time we're going to add a little extra feature to it. It says, use implicit differentiation to evaluate the derivative dy by dx at a point for the function x cubed minus y cubed equals 0. Okay. So before we can actually evaluate the derivative, we have to first differentiate. So remember, your implicit functions are functions where, in simple words, I would say is where you have powers of y, or you have mixed values of the products of the x and the y's, or the sine y's, or as we have been seeing before. So step 1, you differentiate both sides of the equation with respect to x. So differential of x cubed minus y cubed equals differential of a 0, which is simple as 0. Then the left hand side is differential of x cubed minus differential of y cubed. Now the x and the x is fine, whereas the second term x and y are not the same. So here you're going to do the chain rule. So you're going to get this 3x squared plus minus 3y squared dy by dx. Now remember, step 2 is getting all the dy by dx's on one side of the equation. And when you do that, you get negative 3y squared equals dy by dx negative 3x squared. Now we don't even need to do step 3 over here because there's only one dy by dx. So we straightforward apply step 4, that is solve for dy by dx. You get all the other terms on the right hand side. You get dy by dx is x squared over y squared. So to find the value of the derivative at a point 1 and 1, that means you're finding dy by dx. You're evaluating this at 1 and 1, which is basically you're finding the value of the function x squared y squared at 1 and 1. X is 1, 1 is 1, answer is 1. So we have done quite a lot of implicit differentiation. And we, as usual, are going to do some practice problems. Just remember, one simple way when do you do implicit differentiation is when you have terms of the kind y squared, y cubed, or you have x cubed, y cubed, or you have cosine 2y. So expressions where you see where a y is being multiplied, a product of the two variables x and y, or a product of y with a higher power than 1. So all those terms are the ones which tells us, oh, we need to do implicit differentiation. Just keep the simplest rule in mind. And then in the next video session, I will be doing the rest of the problems related to implicit differentiation. Thank you.